Hello everyone, good afternoon. I'm glad to be here to share a paper. I'm Chen Gong, come from the University of Virginia. First, I want to introduce the research background of our works. Actually, the various privacy leakage problem in the image synthesis area. We can see this example. This is a training data set, and this is the generated images from the generative models. We can say that the generated images and the training datasets, they are quite similar. So it has the problem of privacy leakage. And this paper told us that it is necessary to develop safe generative model for private image data synthesis. So how to solve it? One of potential solution is differentially private image dataset synthesis. I want to use a small example to describe this task. It's a hospital, and this hospital will have some medical images, and they are sensitive. Differential privacy dataset synthesis including various types of dataset synthesis, like graph and tabular dataset. But in our paper, we only focus on image synthesis. Return back here. Directly releasing this dataset to do some downstream task, they have some privacy leakage problem. And then we can train a data synthesizers with DB guarantee. And then we can use it to generate some synthetic data. And this synthetic data, they are both fake data. But it is noted that then we'll have the similar distribution of the original dataset. So we can release this dataset to the researchers. And researchers can do some downstream tasks on that without privacy leakage concerns. Yeah, I have introduced the concept of differential privacy many times, so I tired of introduce this concept. Overall, DP ensures that the analysis results don't change significantly when adding or removing a data point. And the next problem, how to train this model to satisfy DP guarantee. Actually, the solution is so naive. We can train the deep generative models using DP-SGD to do that. Previous works generated similar images in MNIST dataset, but they did not show the result of more sensitive dataset, like face dataset. However, we found that it is harder to process complex synthetic dataset by directly using DP-SGD to train the diffusion model. So, there are some works work on overcoming it and improving the DP image synthesis performance. In this paper, they propose that if we have foundational models, we can use it to generate some synthetic data set at first. And then we can make this synthetic data set more close to the private data set. But it is noted that these two data sets, they are not exactly the same, because in order to satisfy the DP guarantee, we should add some noise to this distribution. But in this paper, these foundational models have seen images similar to the sensitive data set, and we hope to follow another kind of assumption. Leverage public data set. Actually, pre-training technology is widely used in multiple computer vision tasks. And the pre-training technology helps to capture the basic image synthesis ability before fine-tuning. So we can look here. Pre-training on some public dataset. The public dataset can be released on some open source platform like ImageNet and Coco and others. So we are curious how the pre-training impacted the performance of DP images synthesis. And now, I want to introduce one of the solution, SOTA solution here, which is Pretraining DP diffusion, and we call it PDP diffusion. We can see this picture. Yeah, we can pre-train the diffusion model on the public dataset, and then fine-tuning it on the sensitive dataset using DP-SGD. And then the fine-tuned models can be used to generate a synthetic dataset. But studies indicate that if the pre-training dataset is not similar to the target dataset, the effectiveness of the pre-training dismisses. Therefore, we raise the question, can we use some method to select a part of public dataset and make this public dataset's distribution closer to the sensitive dataset? Therefore, we can improve the synthetic performance. So, we proposed our method, PrivImage, and we do this semantic-aware selection to the public dataset. So the question is here, how can we obtain and what is the semantic of the sensitive dataset and what is this for the public dataset? So how to build the semantic for images? Yeah. In our paper, we focus on the semantic images. Semantic is a kind of high-level description of images. In this paper, we use it. We can see these two examples. The semantic provides a high-level representation of images, and the semantic captures the meaning of images. For these two pictures, the different at the pixel level, but the similar at the semantic level. They both have the same semantic dog and man. Yeah. In some scenario, there's some open source semantic query function. We can directly use them. But in some scenario, if we don't have the available query function, yeah, how can we do that? We can construct it from public dataset. Yeah. Most public datasets have the semantic labels, like caption and the category labels. We can use the category labels and captions to help to train the semantic query function. Yeah. Here is the loss function, and I want to go to details. But high level of the ideas equals to solve a multiple classification task. Yeah, this is a simple example. This is a picture, and we can input it to this function, and it can output a vector. And we hope the output semantics equals to the images, captions, or label category. In here, we do some experiments in here. This is a CIFAR-10 dataset, and we use the semantic distribution to obtain the type 10 semantics. We can say that they're quite similar to the labels of the CIFAR-10. So this presents that our query function is accurate. But sometimes, if the caption, labels, and others, they are both available, how to train the query function? Yeah, actually, we don't have a good idea now. I don't know how to address it now. So if you have an idea, please contact me. And the chair told us that more than 50 co-authors helps to improve the accepted possibility, and we still have persistence now. And then we can use the semantic distribution to select the public dataset. But before that, we should add noise to this distribution to satisfy DP guarantee. Yeah. But we know that it's a simple step, so the privacy budget cost is quite small here. And then the selected public dataset can be used to pre-train the diffusion model, and then we fine-tune the diffusion model on a sensitive set with DP-SGD. And we know that the two parts should cost the privacy budget. One is in here, another is the DP-SGD. So we can use RenE DP to account the privacy budget here. And then I will introduce how to evaluate our method. This is ImageNet method, ImageNet dataset, which is the pre-training dataset. And we also use the Lab A, CIFAR10, and the skin disease image dataset as a sensitive dataset. This works point out that we should not use ImageNet as the pre-training dataset and the CIFAR10 as a sensitive dataset, because the ImageNet dataset contains images that are quite similar to those found in the CIFAR10 dataset. Yep. We just curious how our method performs in this dataset, and we will also explore the performance of other types of dataset. Here's the Lab A and this one. And then I will evaluate introduce our evaluation by answer two research questions. The first one is how effective is PrivImage for synthesizing useful images. Actually, we list various values in our paper to highlight the strengths of our method. But in here, I prefer to not present them. This is a synthetic dataset. We can use it to train a classifier and extract the embedding from this classifier. And then we can use the TSC method to reduce the dimension of this embedding. And these two TSC pictures show that the synthetic method the synthetic dataset by our method have a more clearly boundary than the baselines. We also present the visualization of our method and the baselines here. In the research question 2, we want to explore is query detection useful? That's right. In here, we directly pre-training the generative model on the public dataset, but without fine-tuning, and directly used it to generate synthetic data. Before fine-tuning, PrivImage produced synthetic images with a data distribution more closer to a synthetic dataset. We also had a discussion to explore how the synthetic dataset performed to defend against membership influence attack. Actually, we didn't conduct this attack at first, as we believe that DP provides a theoretical framework of privacy protection. But the reviewers prefer us to conduct a related discussion. So I selected this membership attack because it is the simplest way to replicate the MIAA for diffusion models. So this story tells me if I want more citations, refine my open source repository. In summary, our paper can reduce the size of the sensitive data set to use a small diffusion model and a small size of pre-training to finish this task. So it can overcome two questions. The first one is DP-SGD will introduce some stable diffusion. And the next one is that a large pre-training data set used a huge computational cost, and our problem and our questions, our method can overcome these two issues. This paper proposed a DP image synthesis method using diffusion models with Semantic-Aware pre-training. So this is all my presentation. Thanks for listening.